All right. Hello, everyone. Cool. Today I want to talk about just the basic objects that are in JavaScript and kind of just go over how to use them. And then most of this, like most of what's useful, I imagine, will just come out of questions and come out of like clarifying questions and maybe some misunderstandings about how you currently think about these objects. Does anyone have any opening questions? Does everybody know what these objects are? Does anyone not recognize any of these objects? Everybody knows what this one is, huh? What's this one? You don't know it? Not a number. Yeah, it's a little bit of a weird one. It's about how JavaScript handles some math cases. But let's start with object, the object. Let's do this. Okay. Can everybody see this? Great. Okay. So an object literal. So I'm talking about object and it's big O object, right? So this means a couple of things. This is like the concept of an object, and you can read about like the specific docs on what an object is, but there's also this actual variable, global variable in JavaScript called big O object. Well, that's new, that little F there. And so there's one thing to know about the console here, that if you log some of these objects, it's just going to tell you that big O object is a function, and its code is not written in JavaScript. Its code is written in the language itself. It's built-in part of the language. So in the case of the browser here, that's we're running V8 in Chrome is the JavaScript virtual machine environment. So that's probably written in C. And so this code doesn't actually exist in JavaScript. So it's kind of only showing you that like this is a function and it has some unviewable code in it. In the console, you can do the dir command and give it an object, and it'll give you a different view into that object, and it shows it to you as kind of as an object, which might be confusing, but basically as a thing that has keys and values, right? So that's the main thing about almost every single thing in JavaScript, is that they all are objects and they all contain keys and values. So if we make just an object literal, my object equals curly braces, I can see that this object, by opening it up, has no properties on it, except it has this one special __ proto property. And we might have time to get to that today, but right now I just want to talk about how, at least for objects, how you can give it a key and set that to some value. And then if we look at this object again, oh, I just reset it, my bad. If we look at this object again, it has the color green, or the color property with the value green. Okay. Another thing to know about objects is that keys are always strings. So even if we say my object bracket 42 equals something, if we look at the keys on this thing, in this display here, they don't really look like strings, but if you were to do object.keys on your object, these all are treated as if they are strings. So even when we use a number here to access this property, it's getting converted into a string, and then that's the key. So we wouldn't have, for example, two keys, where one is the number 42 and the other one is the string 42, and we could put two different values in there. You cannot do that. Each key is turned into a string whenever you try to reference it. And so if there are any questions at any point as I go through explaining these things, please raise your hand or just interrupt me, and
Did you talk about the proto object yet?
The what?
The
the proto object here is another special property that are on objects, and I'm going to get to that in a second after I explain some other objects here. Cool. So any question? Oh, yeah.
Is there a reason why the object keys are always strings?
There might be a good reason for it, but it's at this point just a fact of the matter. It's just a fact of JavaScript, and so it's really just something to know, but I don't know why that was a design decision for the language. It seems pretty simple to me, so that might have just been the design decision, is that rather than have the keys of an object be able to be complex things and be able to have the key be actually an object or something other than a string, just makes things more complicated, right? If I had an object that had a property name or a property 42 and a property of the number 42, and those could have different values, that might be a little confusing. I'd be having to switch types all the time. I'd have to be type checking my keys all the time, and that sounds like a pain. Yes.
Are keys also symbols at all?
There is a concept of symbols that's been recently added to the language, and yes, you can have keys be symbols, and I actually don't know as much about that. I haven't found a case to use symbols. Even like some of the new iteration stuff and factory stuff uses symbols for a lot of things, and I have honestly have had very little experience with symbols in JavaScript, so I'm not going to cover that today. But there is another new thing in the language about that can be a key, which is a symbol, and a symbol is basically just like unlike a string where you can have two different strings that are both, a string over here is Jared and another string over here is also Jared. A symbol of the symbol Jared is always the same, and so it's handled a little bit differently. You can't have more than one copy of it, and it's used to optimize like how much memory we use because we can only have one copy of it. So, and I won't go too much more into that, but there is this other thing, you're right. So if you see that, I think it's like 2 @ symbols or something. So just so you know what it is, if you see it, there's like, where have I seen this? I just saw it in a doc I was looking at earlier. I can't find a good example for it, but yeah, symbols are a thing. Okay, cool. So these are the basics of an object. And so an object is a data structure that is based around a key equals a value. There's no other way to put information into an object except for giving a value to a specific key. And so this is the core of how almost everything or every other object works in JavaScript. So I'll talk a little bit about this proto thing now. So we see that my object has 42 in color, so I can do color. Oh, I guess I'll mention this. There's dot notation and bracket notation for accessing property values. And we say keys and values, but in JavaScript, I guess the appropriate word is property. Even though it's like object keys, they call them properties in like every other doc. So that's not like a hard and fast rule, and maybe I'm even wrong about it, but I think I call them properties because there's all these other like methods like has own property and stuff. So I think object.keys instead of object properties might have just been for brevity's sake. Cool. So my object I can access by dot green here or dot color here. I can also access by passing in bracket color. So we've got this dot notation for accessing properties, and we've got bracket notation. And these are pretty much the same thing. They just have a couple of different use cases, right? There's 2 main things about keys. So for example, my object dot 42, that does not work. So you cannot access a key using dot notation if it doesn't fit a subset of the characters that are allowed in a key. So you can have a key that's called 42. You just have to access it like this or like this. But you can't access it like this. But if we had a key that was like size 43 equals, I don't know, small or whatever, then yes, this matches, right? So it can't start with a number, I think is the rule here. A key can't start with a number, but it can start with a string and it contain numbers. Excuse me, it can start with an alpha character, I guess. So there's some rules here on like what words are allowed to be used or what syntaxes are allowed for dot notation. I don't know all the rules, but I think it just has to start with an alphanumeric character, and it can't contain a space, right? So we can have a key that's like my favorite show, which, do I even need to say it? Right? And then you obviously, this would be a syntax error if we tried to access a key off an object like this, right? The language couldn't support this syntax. It'd be confusing. It needs that freedom for other expressions. So we have to access this key by passing it as a string with spaces. So there's probably other rules in there on like what's a legal dot notation key and what's not. But you should be aware that depending on what your keys are, some of them are going to be accessible via dot notation, and then some of them are not. Yeah? So then you'll notice I get, in the Chrome Developer Tools, I get tab completion in some sense. If I do my object dot, it knows color and size 43 are properties that I have. I think it knows that because I've accessed them before in the terminal. But it also has these other things like has own property, right? This is a property on this object, and the value is this built-in function. It's another one of those core language functions that doesn't have source because it's written in C, right? Does that part make sense? Does anyone need clarity on that part? What this native code thing here means? Yeah, sure. So functions can be written, a lot of, or most functions are written in the language itself, right? Some functions are provided in the language, but their actual content, what happens when you call them, isn't written in JavaScript. It's written in the language that JavaScript is implemented in. So JavaScript is a language that can be implemented by other languages. It's got implementations in C, in Java, and probably some other places, right? So what's happening there is you take a language like C, which is a much more verbose specific language where you have to do a ton more stuff manually. You have to like manage memory manually. So there's like this lower level language that we can implement the language of JavaScript in. And so when we run Node, that's actually a program that was written in C. In C, I think. Fact check me. And so when you implement JavaScript in this language, you have to write has own property. You have to implement that in the implementation of the language, not in the language itself. I'm trying to think of a good analogy of this, and I can't think of a good one.
Yes, Node was written in C.
Node's written in C and C++. Okay, great. So we take this lower level language and we start implementing like, okay, you wrote a JavaScript file. I'm going to read that file. I'm going to go character by character and I'm going to like parse your JavaScript, and then I'm going to do the work that JavaScript instructs, right? So the work of doing the language of JavaScript is written in another lower level language. So that lower level language is where this was implemented. So we can't see the code for this function because it's written in a different language, and it wouldn't be helpful for us to see a bunch of C code here or a bunch of Java code here, right? So this just says this function is implemented at a lower level, so it's basically hidden. You basically can't know what its source is. You have to know what it's going to do based on the documentation for the language.
So what would you use my object that has own property for?
Well, so that's a different question, right? What does has own property do is kind of tangential to my point. Like, there's just these other functions. But the point that I was driving to, and we can talk about that in a second, but the point that I was driving to is that this object we created that only has these 4 keys on it also has some other keys that you can access. So when I say dot color, I get back green, but when I say has own property, I get back another value. This property exists, or this property is accessible on this object, but it doesn't come from the object itself. It comes from this other object here, which is the sort of top level object, or it's an object that has keys. It's another object that has keys and values, has properties and values. But all objects, when you ask them for a property that it doesn't have, will defer to this object to see if it has that object. So we can look at this object and we see that it has like toLocale string. I honestly have no idea what that does. But all objects, if I ask for toLocale string, it will return the value for that. And what's happening here is it's looking in this object and saying, I don't have this property. So look at my __proto object and see if it has that property. So there's this little bit of like inheritance, or I think it's more clear to call it like property lookup deferral or something like that, right? So if you ask me like, what is your color? I'll say, I don't have a color, so ask Michael. Michael, I defer to Michael. He's my so it's like we have layers of objects here, right? So this object is what almost all objects in the language will fall back to if they don't have a property.
So this is almost like an object default.
It's like a super object, yeah.
But it's on every object.
Well, every object eventually will ask this object for if it has the property that you're looking for, right? So if I just make a brand new empty object here, it has no properties on it, but I can say .toString, and it will go get the toString value from this. You could think of it as a parent object, but it's basically the object that all objects defer to when they don't have that property.
So proto is its own object.
This object here, which is called the object prototype object.
Object prototype object?
Yeah.
Okay.
Yeah. It's sort of like, they call it the prototype because it's sort of like, here's what all objects should look like. It's the prototype for objects, and then all objects sort of look like that object by just deferring property lookups to that object.
So it's like a global.
It's kind of like an ancestor. You can think of it as like a parent-child ancestor sort of relationship, but it's really, I think, easier to understand it as just like I'm a list of keys and values, and if you ask me for a key that I don't have, I defer to another object, and then I proxy ask that other object. So, for example, if I create, if my object.toString is going to go get that native toString object, but I can set toString to something else, and then it'll return that because this object now has a toString. But if I delete my object.toString, if I delete this variable or this property from this object no longer has this property. So then if I ask for toString again, it now says I don't have it. Go ask my prototype.
Okay.
Cool. So in the JavaScript console, it's really useful to type out your object, and you want it to be kind of like the first thing in your expression. You don't want to be like a.b.c.d, right? So if you just put this in a variable and then just say dot, the console will give you kind of like a drop down that says like, here are some of the things that you can call off this object. And then again, another way you can look at an object is pass it to the dir command, which is, I think, an alias for console.dir, which is special to Chrome, I think. It might be in most browsers, but I know Chrome, at least the Chrome developer tools, which is the only ones I use, have this, which will list an object and show you its keys and properties.
Jared, is there any difference between defining an object literal or like with bracket notation versus declaring it as a new object and then defining it that way?
So saying new object?
Yeah. And then
I don't know what why you would ever do this. We could look at the docs. There may be some tricks that does or some special functionality that provides, but I don't think so. I just standard literal expression is fine to declare an object. Okay, cool. Okay, cool. So all of the objects in JavaScript should serve to have properties and values. So if we just look at a number like 42, we can say, what is a good method on you? Let's go dir on 42. Oh, that's not helpful. Well, that just called me a liar. Look at that. I can't think of a single number function. Sure, okay. So, numbers suck. Let's do a string. Oh, you're doing it to me too. Okay, well, okay. So for example, strings have two uppercase. Okay, so this is a string. You may not think of it as an object, but it is an object in the sense that it has properties and values. So if I call to uppercase, this is a property that gives me back the function to uppercase, right? And that comes from, I think you can do this. This comes from the prototype object for strings. And the prototype object for strings is where we get all of these string functions that we're used to having, right? Like, I didn't even know big was a thing, but like we've got, I don't even know what that does. We'll see. We've got match and repeat and replace and slice and subster and to uppercase and all these different string methods that we might have used before come from the prototype of a string. Right, so if we
Answering
do
all the questions.
hello.to uppercase, it's going to uppercase that string. Now I got to see what big does. Okay, that's not super useful.
What's the difference between two?
Okay. Who's doing web development?
What's the difference between two locale uppercase and
I have no. I assume it has something to do with localization, where you can say like this browser knows you're in French, so we're gonna uppercase in a French way. I don't know. Maybe there's probably different languages. I assume have different ways of casing things. I have no idea. But locale is a localization, so internationalization. Yes.
I was just curious, like when you go to MDN and stuff and you're looking at prototypes, it always has like date.prototype, get month, and stuff like that. But you never use prototype when you're actually like using that method, right?
Yeah. So
why is it necessary? Why do they even use it?
Well, it's just the way the basic objects in the language are set up, and it's also the way prototypical inheritance works. So it's another feature of the language, but it all boils down to this. A lot of this stuff's complicated, and I find it really hard for people to sort of internalize and make intuitive because it's not intuitive. But it all boils down to this thing to this simple idea that you have an object, and an object is something with keys and values, properties and values. And when you ask it for the value of a property, if it does not have that property, it will look at another object and ask that object, "Do you have this property?" And then you can chain those things. That object can say, okay, I don't have that property, but here's my prototype. Go ask them. And you can say, okay, I asked this object for a property and it asked this one and then it asked this one. And you can do this sort of chaining of objects that defer to other objects, to one other object, when they are asked for the value of a property they don't have. So that's what's happening here when you have a string. String.big, we're asking it what's the value of the big property, and it does not have one, but it goes to its prototype, this object here, which is the same as string.prototype. These are the same objects. So string.prototype is an object that serves as the sort of fallback, the deferred property object for all strings. So if I wanted to make
What was the same as that? You say that one more time?
so string, capital S string, which is a global object, dot prototype, is the same object as any string. The object they defer to. Every string defers. These are the same object. Okay, so if I go string, and you should probably never do this, that prototype dot awesome equals a function where I return. Here, I'll do it inline like this, where I return an awesome tag. Okay, so now I can have a string. Oh yeah, where am I going with this? Oh no, I messed it up.
You're not
I messed it up.
awesome.
I can't use these kinds of functions. I screwed it up. My bad. I can't use an arrow function. Sorry. I know. The shame. I'll never live it down.
Why can't you use an arrow function?
We can talk about arrow functions in a second. There we go. Okay.
Yay!
Cool.
Awesome, Jared. Awesome.
So all strings, if you ask them for the awesome property, they now say, I don't have an awesome property, and you should defer back to my prototype object and go see if it has one. And then you have one. But so notice the prototype object pointing at the screen doesn't help anyone. That also does not help anyone. So you'll notice that the function I defined can actually use the string itself, right? So even though this object is deferring to another object to go get this functionality, like 2 lowercase and 2 uppercase is on a different object that we're deferring to, we can still use the original object. When we execute that function, it still has the context of that original object that we were talking about.
So instead of adding a prototype awesome, if you add big, is it going to stop at the big you define?
Yeah, so this is probably a special case, but let's find out. Let's find out. Because there is a slight difference between, there is a little bit of special casing between some of the literal basic objects, so like numbers and strings. So like name, I can go get big, but I don't think I can assign big to another thing. Yeah, so strings and numbers are like, I don't know why, this is a guess on my part, are primitive objects, and so it wouldn't make sense to give them extra functionality, right? So if I define the string Jared and then I want to give, it's like, it is an object that defers, but I think it's an immutable object in the sense that like we can use this string to generate another string, but I don't think we can add properties to this. And I don't think we can add, I don't think we can add our own properties to it. Unlike a standard curly brace object, you can obviously add whatever properties you want to that. But strings and numbers, like adding the property jump to the number 42, I don't think makes a lot of sense. So I don't think the language allows that. It probably should for strings, but it clearly doesn't. What is what? Oh no, it's only doing that because I've historically typed .frog off of, it's just trying to match previous. Yeah. Cool. Okay, sweet. So now let's look at arrays, unless anyone has any more questions about that weird prototypical inheritance thing.
No,
No?
that makes complete sense.
Oh yeah, hi.
Did you say it's like a primitive object? I thought primitives were the opposite of objects. Maybe totally.
They're not the opposite. I think the word primitive is just used to talk about like just an incredibly basic or simple or low level object. Like it doesn't get it, at least in the case in JavaScript. I think what I mean here is that it just does it can't be decorated with new things. You can't augment. It's immutable in some sense, right? The number 42, you can't change the meaning of 42. You can't change that object, right? Strings are make a little less sense to me. Like it makes sense that you could modify a string, but but clearly the language doesn't support it. So I don't know that I have a better technical computer science answer for you, but that's the real world of it. Yeah.
So basically everything, whether it acts as it or not, is an object.
Everything has properties with values so it has that part of being an object. Not everything can be given new properties,
Right.
but they still, the way you interact with all objects in JavaScript is that you ask for the value of a property, basically.
So all the primitives can't be music, but the reference types can. The arrays and objects.
Yeah, I actually am not even sure, because I never do it, whether if I make an array, I don't think you can. Something new equals an empty function. I don't even think you're allowed. Oh, okay, you are. You are allowed to add properties to an array.
Okay.
But some objects do not allow you to do that. Like for example, booleans, like true dot. If I wrap true dot foo equals, that doesn't make any sense, and I don't think that is going to persist. Right? Augmenting these objects doesn't make sense. But true, I believe it's going to do that same thing to me, isn't it? There's probably some method off this, but maybe not. There'd be boolean dot prototype. Has any functions on it? Yeah, so we could say true dot, toString. So another case here, true doesn't make sense for us to modify that object.
Yeah.
It's immutable, but it does have properties that come from the boolean type prototype.
Cool.
Does that answer your question?
Yeah.
Yeah, cool. Sweet.
It's not entirely correct to say a string is an object.
Well, it's an object in the sense that it has properties and values, and you can ask it for the values of its properties. And so it's in that sense of the word object, it is an object. Yeah. Okay, cool. So another question. Where is it? Hi.
So whenever we alter prototypes like that, add functions to it, does that just persist as long as the window's open?
Yes, it persists for the session of the JavaScript environment. Yeah. It's also like a really risky thing to do. So it's totally doable, but it's generally frowned upon by the entire JavaScript community for like historical reasons. Even though we do it a ton in other languages, like it's no longer really wildly. If you wrote a library that did it, few people would probably use it, I would think. Yeah. But that's how it should works. If anyone's used to the should expectation format from Chai, like where you can say .should on every object, they just went into the object prototype and added it, right? Cool. So remember how I said object is sort of the base object for everything. So object.prototype dot everything has this. Yup. So I think. Let's see. Does true have this? Yup.
Does 42 have it?
42 should have it. Yup.
So when you want to be able to access something, like, could you give an example of, like, let's say you're writing out,
there isn't a good use case for extending every single object with something. It's something you should probably never have to do.
Okay.
If you're doing it, you're doing something super tricky, like a .should expectation extension to the entire language, right? Like, which I don't use that thing because I think that's a ridiculous way to solve that problem. But this is something you can do in the language. You may see it, you may see other libraries do it, but I don't recommend it, and I think everyone would frown upon it.
and that's like creating an alias, right, for that one working session?
Well, you're trying to draw an analogy to like an alias inside of a terminal? Is that what you're?
I guess, or just that you're creating, like, okay, for this project I'm working on, and this, I'm gonna create this little keyboard shortcut.
Sure. If what you're asking is, does extending object like this persist outside of reloading the page or restarting the JavaScript environment that we're in? No, everything resets back to defaults and you'd have to run this code again to get that functionality back. Okay, cool. Yes.
Is there an easy way to save that? Do you want it to persist?
Nothing saves. You have to just rerun code every time you want that to exist. So every time we load, a web page that uses jQuery to modify the DOM, we don't persist the fact that jQuery exists. It just executes that code every single time. So the nature of JavaScript, and this is probably true of most dynamic languages, that when you boot that thing up for the first time, it starts in the same default state. And if I need a library to talk to a database, I've got to execute that code. If I need a library to do something else, I've got to execute that code. And I don't know of a language where you get a library that lets you talk to like a Postgres server, and then that's just permanently added to the language. It's always something like, here's some code that if executed will set you up to do that job, and you must execute it to get it. And you have to pay the cost of telling the processor to put those things in memory, and all that work has to be paid every single time. Yeah. Cool. So arrays, how are arrays like objects? It's a little bit different than what you might expect. So if we have colors, oh yeah, I've done this before. Okay, cool. So here's our array. And how would we get yellow from this array if we wanted to get it?
Colors.
You can use bracket notation. Okay, what am I gonna put?
1.
1. Great, cool. So before we saw when I did my object and I did bracket 42. Oh, did I reload the page or something? And we do bracket 42, we can get back the key 42 from this object, okay, when we look at it like that. If we look at colors, colors is actually an object.
Yeah.
Okay, it's a thing with properties and values. It just happens to store all of its properties with the all of its values under the property of the index, right? So if I come into colors here and I say your 44th index item is I don't know, purple. We have 0, 1, 2, and 44. And it stores the length. So now it's just the highest key plus 1, right? The highest index plus 1. So this array is really, when we say colors bracket 2 to get back, that's exactly the same as what we're doing here when we say my object bracket 42. We're just saying, give me the value at this key on this object. Yes.
So it made 41 undefined things in the array when you said 44 is purple. So
I mean,
are those actually in the object? So if you were to call now object, or in the array, so if you were to call array at position 43, would it return?
so that's just true of any array. Here's an empty array, and I call at this index, right?
Yeah.
That's just telling you the same thing as if I made an empty object and I said, what's in the key? It's also undefined, right? So while we have to be careful about the way Chrome displays things to you because they're trying to be very helpful in what they're displaying to you. So they're telling you this syntax where you say left bracket thing, comma thing, comma thing, that's a way to write an array literal. And they wanted to make it clear that there's this, instead of doing 41 undefined, comma, they're just trying to be helpful here. But like that's one way of representing this array. So this array that only has these 4 things in it, if we wanted to write this as a literal thing, we would have to say red, comma, yellow, comma, green, comma, undefined, comma, undefined, comma, undefined 44 times, right? So it's just trying to illustrate like that's how you would write this in a literal way, even though internally, no, it's not storing that. So we can show that by what would be the difference if it was? Well, if colors 10 was actually stored as undefined, then it would show up in this object as a key, right? So that's another thing I didn't talk about with basic objects is the sort of default value is undefined. So again, if you make an empty object and you try to access, anything, it's just always going to come back as undefined. If that property doesn't exist anywhere, this is the default value for it.
Okay, so tell me if I'm wrong, but in JavaScript, an array is just an object with automatic indexing. So the language provides the indexing, but it really is an object. Is that right?
Yeah, and I don't even think the language provides indexing. I mean, it does when you do the literal syntax of it, right? But like if I wanted to push something into the 3rd index, like I'm literally saying 3, right? And if I want to use the method push, the method itself is looking at the current index, adding 1, and shoving the value into that key, right? So it's still being done with methods on the object.
So arrays in JavaScript is different than arrays in the language like C or something.
I actually don't know very much about C and C++ and how their arrays work, so I can't tell you that, but I imagine it's different. It's very different from the way arrays work in like Ruby and Python and Perl, which I'm more familiar with. Well, actually, I'm not even super familiar with Python, but
I'm very familiar with Python, and yes, it's very different.
Great. So in JavaScript, arrays happen to be a kind of object, whereas in other languages, and we're getting into sort of nebulous definitions that change from language to language and are used as like general programming terms, and they have similar shapes. But when we get down into the specifics about JavaScript, arrays are a type of object. So and that's useful for you to know because you want to know that everything has has properties and values, and you can list those properties. And when you access those properties and they don't exist, they can defer to other objects. And like you want to know that is true about arrays as well.
I'm sure you're gonna go there, but can we see the proto for array?
Sure. So it's
same
got
as
fill and
object.
filter and find and for each, right? And all these array methods that we're used to, and that all comes from array.prototype.
And is it the exact same as object, or is it different?
No. In fact, the array prototype defers to the object prototype, right? So that's how arrays have things like these basic functions, has own property in toStrings, because the array itself looked at the array prototype, it didn't have it, so then it chained down and looked at the object prototype. So if we have an empty array and we call toString, this actually came from the same place that all objects toStrings come from. You can't do that with numbers.
Jared, it looks like there's actually a toString on the array method.
Oh, is there?
The prototype method.
Oh, then yes, then we would have gotten this one. Yeah, and it's going to be different. It's going to toString in a little bit of a different way. Cool. Yes.
Is the object prototype different than the proto? Or are those two things referring to the same thing?
They refer to the same object, but this whole like underscore proto thing is not something that you should like use in your programming. It's only here to help you sort of introspect these relationships. These relationships are constructed and defined in a different way, but this was here for you to help like debug. So when you look at an object, you can see that this object defers to this. But if we look at an array, you can see that an array defers to the array prototype, which then itself defers to this base, the base object, the bottom object.
And then there's a get prototype and a set prototype.
Well, these are different.
Okay.
This is a getter and a setter for this property, and we don't have. I'm not going to get into getters and setters right now because
Okay.
yes.
My understanding is that the proto like on object is help you to mutate an object without affecting the original object to create a prototype of the object. Is that correct?
Say that to me again.
So my understanding that the prototype is that to create like not a copy of the object, but to be able to mutate like some information of the object without affecting the original object. Is that correct?
I don't understand the last part, the without affecting the original object. I think what you're getting at is that we can have several objects, right? So for example, several arrays. So we can have a bunch of arrays here. Yeah, I'm not going to spell it right, okay? Cool, so we can have these three arrays, right? And I can then go onto the array prototype and define, you know, each instead of for each. And I'm just gonna make it a copy of for each, right? So I can modify this underlying object, and now every single one of these objects that defers to that, all of these arrays now have been sort of extended with that functionality, right? So that's the motivation behind having an object that is considered the prototype of other objects, is that you can modify that prototype, and all objects that defer to that essentially get that extended functionality, right? I just added each as a copy of for each, so now I can type dot each instead of for each. I'm saving all the time in the world. And so now I can go to any array I want, even ones that don't exist yet, and I can say dot each now. Or I could add a magic filter function that was a special version of, or whatever, right? Whatever array-based function I want, I can add that to array prototype, and now all arrays get that functionality, right? So that's really the motivation, is that I don't have to go around to my 1,000 arrays and add them with this add a new function to all of them. I can add it to one place and they kind of all get it. Does that make sense?
It does. Like one time in the Chrome, like if I have an object, let's say like cars, and then I do like cars.proto, and then it will do like I don't know how to explain it, but like it will do like a sub object. But you can mutate the cars on proto without affecting the cars object.
I mean, it's exactly the opposite, Sal. I think it's the point of modifying. So if it didn't get picked up on the microphone, Sal's talking about using a constructor like car to create several instances of cars, right? And you were saying that if you modify the car prototype object, it wouldn't modify the individual cars, but it's exactly the opposite, right? So this getting into constructors, which I wasn't planning on touching on, but basically if you create a constructor and you instantiate several instances of that constructor, and then you modify that constructor's prototype object, you will modify, in a sense, the instances as well, right? Because they defer down to the car. So if your car has like a start engine function on it, and then you make 5 cars, they all have a start engine object, not because they have them, but because they defer to an object that does, right? So if you go add an e-brake function on that car, then each of those instances, since they defer to this object that you've modified, now have that function, right? Now have that method. All right, so when we have like colors.push and we add a color to this, it added it to the end of our array here. And colors.push is another one of those native functions that this object does not have. It does not have its own push function. It got the push function from array.prototype. Cool. So does everyone see in that this relationship between all objects and how they defer properties and stuff?
Mm-hmm.
Cool. Okay. What should we do? Cool. So we have all of these global objects here. So just review object.prototype. This is the object that almost every object, if not all objects, eventually defer down to. And then we've got these higher level objects. So like array.prototype is kind of a layer on top of that. So is date, string, and number. So we can, just like we did with number, we can say string.prototype. Oh, we did this, right? We did a dot awesome. Yeah. So we can extend those things. Cool. Cool. So if we look at something like a date, this is actually kind of this is another one of those objects where it does not have any of its own properties. It actually stores the value of itself, like what is the actual date here, sort of internally. It doesn't put it on like on a property of itself. But we have another of these same relationships where date.prototype has a series of functions on it, and every date defers to this object. So we can say, we can have our date here, and we can say like get day or get month. And these functions all exist on that other object and are accessible here through this prototypical inheritance slash prototype or slash property deferral thing. Yeah?
It's kind of brilliant.
Cool.
I didn't know any of this until.
Great. Cool. Sweet. So there was, yeah, I don't have time to dive into any deeper into these other objects, but we've talked about some really good core concept of the language here. So let's stay here and just to make sure we answer the rest of the questions.
I was just wondering, would you also add error to JavaScript primitive types? An error, like new error?
Add an error. Oh yeah, sure. So like error.prototype is a thing, right? And so if we had a new error, and we looked at this object with dir, we'd see that it has the message I fell down. It has a stack trace, which is just a string. And then it has it defers property calls to this object here, which is the error prototype object, I think. Let's make sure. E_proto is the same object as error.prototype. Yep, that's true. And then that error prototype just defers to that base all object. Yes.
And if we ever had questions on any of these like object properties that already exist, we could always just do number.prototype, string.prototype, date.prototype.
Yeah. So for example, if we want to know about filter, we can say array. You can say like just literal array.filter. That'll get you a copy of that function. But you can also get to that by array.prototype.filter. That'll get you that same. Literally the same value because that's the same property that we're asking about, right? If I say this, I say, hey, array, do you have a filter property? It says, nah, check out the array prototype object. And then it says, I got one, here it is. It's the same as if we went directly to the source and said, what's under the filter property? And then, of course, you can't read the code for these, so you'll have to go read the documentation. MDN or whatever else. Did you have another question? Cool. So I'll show you a tool that I don't use very often, but since we're on this topic, it should illustrate kind of how this works from another perspective. So there's this cool method called object.create, and it will generate this relationship for you. Actually, more specifically, it will create an object who defers its property lookups to the object you gave it. Okay, so, and I'll show you. So let's say we have a object called the car prototype. So this is going to be what it's like to be a car, right? So we have start engine. I'm actually gonna do this, and we have pull e-brake. So this object describes what it's like to be a car, and now I can create a car by saying create a new object that defers to this object. So I'm gonna just log in here. Is that still readable? Cool, so if we run this, you'll see that car1 has no properties on it, but its underscore underscore proto is our car prototype object. So that's what object.create will do for you, is it will say, give me a new object that when I call its properties, so I'll say pull e-brake, it will say, I don't have that property, but go look at my prototype, which is the object we gave over here.
And even under that, it still has the other prototypes.
And this object here is just a standard object that we created, which always will defer down to the base object, the normal base object. Okay.
So if you online, if you name that like instead of class car one, like you name that as any object, and then it will inherit the prototype from the car prototype, right? But then if you change the car one, it will not affect the car prototype. It will change will stay within that scope, right?
If you change what object?
So the object.create car prototype, if you call that car, car one. If you change anything with a car one.
So you're saying if I come in here and I say like broken equals true, this adds the broken property to this object, but it does not modify this object.
Is that correct?
That is correct.
Okay.
Yeah. But here let me illustrate it for just a second, right? Car1 is its own object, right? It didn't have properties on it before, but I can add whatever properties I want to it, and it's like any other object you're used to, right? The only thing that's special about it is if I call a property that it does not have, it will ask its parent or its prototype if it has that property, and if it does, it'll return that value. So I can come in here and I can say, go onto the car prototype and say, why are you not tab completing for me? Go onto the car prototype and say that it now has like, I don't know, change oil is some other function, right? Now I can go to car1 and it now will have change oil. Because it doesn't actually have it, it just defers to this other object that can be modified at any time.
Would that be also for us as
inheritance? It's the only kind of inheritance that is available in JavaScript. I wouldn't call it inheritance. I really think it's better to think about it as an object that defers its property lookup calls to another object. That's more specific. But folks will call this inheritance. It's called prototypical inheritance. But I think inheritance, at least from my experience of how inheritance works in a more classic classes and superclasses and stuff, this is a really bad, and this is not really, it's a really bad analogy. It's not really, I wouldn't call it inheritance, but you will see it called that. Yeah.
Whenever we're calling this prototypical inheritance.
Yeah, that's what it's technically called.
You have multiple prototypical inheritance?
Exactly. Yes, you can. So let's say, so this is our car, but we could also come down here and say, okay, now I want to make a supercar. And so a supercar is a car, except it has like, open your nitrous oxide tank or something like that, right? So now you got your supercar, and now I can come down here and I can make car2 equals an instance of a supercar. And so now if we look at car2, car2 has no properties, but it defers to supercar, which defers to car, which defers to the basic object. So this is that chaining.
So that's chaining there, but can I change other things? Like what if I wanted like a truck?
You cannot defer to more than one object. You can only point in one direction.
Okay.
So you can't have an object that defers to 3 other objects in some order or something. You can't do that. You can only have a sort of single linear chain. Like a linked list, yeah.
Is that I'm not sure if that is what it is, but is that the lexical scoping chain?
No, this is not lexical inheritance. No, that's lexical scope inheritance is a much different concept. Yeah. Cool. So takeaways from this are you don't necessarily need to build these things. This tool of creating like a car prototype and then creating an instance of a car or creating a supercar and having this sort of prototypical inheritance, this thing exists in the language. You probably will not need to use it very much. Most solutions to your problems in JavaScript can be done in a functional way and they don't need to be done in an object-oriented way. You can do it that way. You can learn about that, but I think it's honestly trending out of vogue in my experience. So this is not something you necessarily need to do or use, but it's something you need to understand that is an underlying part of the language so that you can understand how these basic objects work and where their methods come from and just sort of how they relate to each other. And then again, one of the other most important takeaways is that almost everything in the language is an object in the sense that it has properties that have values, and those values probably come from an object that it defers to, and that's how we get method functionality. Cool. Thanks, everybody.
Thank you.
Thank you.